Hey guys, I'm knee-deep in a new project, but I want to do a little follow-up on the recent Wavetek XY display restoration project in which I tested some caps and got unknown part on my little tester. These came out of a board that had conformal coating on it, and some of you said, hey, did you make sure to scrape the coating off? Maybe you weren't making good contact. And yeah, I think you were right. However, the test results, I think, are kind of interesting. So first we're going to test it with this inexpensive multi-tester. Then I got a new LCR meter we're going to try out. So these are the caps that have a red end on them. Sprague 30D series, I think. So I definitely am clipped on to where it's got some metal. So yes, you're right, I wasn't making good contact, so it's not a damaged or unknown part, but boy, look at that reading. 2,899 picofarad non-polarized, I believe is the way that reads. It should be 100 microfarad. Let's check another one. Also got a comment from one or two of you that these caps are just garbage. For whatever reason, they do not hold up well over time. And this is 5,065 picofarads. Also, just complete garbage. And here's a different type. Mallory, 25 microfarad, 100 volt cap. Came from, I think, the main board. Let's just check it as well. 1,279 picofarads. Now, in case you're wondering, hey, maybe there's something wrong with my tester, well, let's just grab a new capacitor. So here's one. It's 22 microfarads. And let's see how it tests. When it takes a long time, it's an indication that it is an electrolytic, and yeah, 23 microfarads. So yes, this tester is working, and these capacitors are garbage. Now let's test it with a little bit fancier meter. Got this a while ago, but never did a proper product review. This is an FNIRSI LC1020E LCR meter. I have not entirely learned all the ins and outs of it, but I've picked up on a few things. Specifically, that the frequency matters depending on the type of cap it is. Now, a lot of the inexpensive, simple ESR testers, I think, have a fixed frequency of 100 kilohertz because they're made for checking caps and switching power supplies. Or maybe they have a setting of 120 hertz or 100 kilohertz, so a linear type power supply versus switching type power supply. There's just a few more options. So this we can do 100 hertz, 120 hertz, 1 kilohertz, 10 kilohertz, 100 kilohertz, back to 100. And we'll see when we hook this up to an electrolytic, depending on what frequency you pick, you get a different reading. Whereas other types of caps, say a mica or ceramic low value cap, they're less frequency dependent. This can also check the X, or the resistance, dielectric constant, the Q factor, the phase angle, and ESR. Sorry, X would be reactance. Somewhat related to ESR, I do believe. Anyways, let's see what we get for this. So it should be 100 microfarads. And it's reading 5.5 nanofarads. That's at 100 hertz. 120 hertz, about 5.5. 1 kilohertz, 4.8. 10 kilohertz, 3.9. And 100 kilohertz, 3.4. Obviously, that's not 100 microfarads. Again, let's check a new cap. Just see what kind of readings we get with that. So this 22 microfarad. So kind of odd that at 100 hertz it would read. Well, it's jumping all over the place, isn't it? or sorry, that was 100 kilohertz. At 100 hertz, we get a stable reading that makes sense at 22 microfarad. 120 hertz, about the same. 1 kilohertz, starting to drift a little. 10 kilohertz, changing more, kind of unstable. At 100 kilohertz, it goes all wonky. But this, I'm going to use in a linear power supply, so the 100 hertz, 120 hertz readings make more sense. And yes, 22 microfarad. Let's check another one of these guys. Let's do the Mallory one this time. It's supposed to be 25 microfarads. And we have 1.4 nanofarads. So these capacitors are just garbage, which is why I replaced them. Even though I wasn't reading them correctly, obviously they're garbage. So this is a 20 microfarad 250. I also replaced off the main board. Definitely making good contact on the terminals. And see, this one measures okay. 23 microfarads. Now, I was leaky at full rated voltage, so I replaced it anyways, but at lower voltages, yes, this is how a cap should read. So I don't know why exactly the Sprague and Mallory caps are just absolute garbage. I suggest if you encounter these, go ahead and just replace them. Test them if you want, but man, they are just crap. They're not that ancient, mid-80s. I'll just briefly talk about this device a little bit more. You'll probably be seeing me use this more and more. LCR meters can get crazy expensive if you want laboratory grade, or even the Sencor variety. That's why I held off on getting one for a while, but when I saw this one, I think I got it for 70 or 80 bucks at AliExpress. I figured, hey, I'd give it a shot. One of the nice things about it, I think, is the way you can connect the capacitors. So they have these slots here, and you can see there's some brass metal strips in there. If you've got a cap that has long leads sticking out like this, you can just push them down in there. Read your part. But it also has this, which is a feature you generally just see on higher end devices, the Kelvin clip. Push this in and slide it over and it locks. You get these nice clips on the end. This lets you take more accurate readings. There's this guard on it, shielding, and there's 4 wires. It lets you take more accurate readings, and you get nice clips so you can clip them into a circuit in various places, or on components with small leads. So that's why I typically use it. I believe these also connect up to these, but I can't recall if it came with the probes for these or not, but I haven't used that yet. But you can also plug leads into that. So that's capacitance. Let's try measuring an inductor. Took me a little while to even find any. It's not something I have to deal with very often. I think these are 120 microhenries. So let's just rig this up. And again, frequency dependent components. So your test frequency may affect your reading. Yeah, 120 microhenries at 100 hertz. Let's change that frequency. 20, about the same. 1 kilohertz, about the same. 10 kilohertz, about the same. 100 kilohertz. Starting to drop off a little. Let's try toroidal choke type now. I don't know what the value is supposed to be, but I'm curious to see how this responds to frequency. Now with both capacitors and inductors, there's a lot of factors, like what's the core material, what's the dielectric material. At 1.7 at 100 kilohertz. Okay, jumping around at 100 hertz, but staying fairly constant. I mean, these are a high frequency type core, so it doesn't surprise me, it doesn't change much frequency. And for the second value, so we're looking at Q right now, you can change that. About an 80-degree phase angle at that frequency. Now that most definitely changes the frequency. You can also change the speed with which it takes the measurements. And there's just your flat out DC resistance. So I'm not going to do a whole tutorial on what an LCR meter can do because it's a complicated topic. But if you want to know what the Q factor means and dielectric constant and stuff like that, that's a whole lecture series right there. But if you just want to check to see if a cap is good or not, it's a bit of overkill. But if you're interested in seeing how frequency dependent components work, and if you're rolling your own circuits, this can definitely be a very handy device. And in this case, it backed up my cheapo little tester that those caps out of that Wavetek were indeed bad. That's it for now. Thanks for watching.